So there's only one assertion made by the Earth curve calculator, in spite of the fact that things can disappear with distance.
Tell me all about it.
Yeah, just
How
did.
can they disappear with distance?
Because they get too small to see.
Oh, please do.
They get too small to see. Their angle is too small. The angular...
Great. What's the angle? What's the critical angle?
I'll say it again. Something that's ignored in your calculator.
I'm asking you, Nathan Oakley, to tell me what the critical angle of the human eye is that would make things...
I don't know. Hold on, let me answer him. I don't know. What I do know...
Well, hello everyone, and greetings from Northern Michigan. This is Bob the Science Guy. I was driving into this office this morning and I called into Nathan Oakley's debate show. Now today he was talking about the Rayleigh Criterion, why objects disappear with distance. He has this major problem with it not being included in the curve calculator. But when pressed on it, he doesn't even know what the Rayleigh Criterion critical angle for the human eye is. And it only gets better from here. Let's watch Nathan dig himself a deeper hole. Cue up the music and let's get going.
Same old. So where there is only a single assertion of Earth curve being the reason for anything in the distance occurring, it doesn't matter what the occurrence is, it's always asserted to be caused by Earth curve. That's the general assumption by our opponents.
Okay.
Hey, plain truth.
All right. I was curious about that limit of diffraction. Can you tell me a little more about that?
Yeah, sure. You are.
No, I'm kind of curious about your thoughts on the Rayleigh Criterion.
What about it?
I was curious as to how you feel that makes things disappear. And why it should be in the curve calculator.
No, I didn't say that it should be in the curve calculator. The curve calculator has hijacked these effects of things in the distance disappearing and called it Earth curve. There's only one assertion from the curve calculator, isn't there, Bob?
Yeah.
So everything. Everything.
It's geometry. Yeah.
Yeah, just geometry. So one cause only. Things only disappear in the distance because of Earth curve. Correct?
Pretty much, yeah.
Well, no, they don't, do they, Bob? Things can disappear because of the diffraction limit.
Oh, great. Tell me all about that.
Things can disappear because of the diffraction limit. I just did.
And what is the diffraction limit?
Something that's entirely ignored from your calculations, Bob.
Well, it's completely unnecessary. But you tell me why you think it should be in there.
Sorry, Bob. It's entirely ignored from the calculation. They're not my calculations. I don't want to put anything in them. There's only one assertion made by the Earth curve calculator.
Okay, now, Nathan Oakley trained in the theater. And as a result, he's used to doing things based on a script. And if you take him off of his script at all, he's completely lost. Now, in this case, his script is that the Rayleigh Criterion, or the limits of diffraction, makes things disappear, and therefore, since it is not included in the curve calculator is wrong. He is insistent, for reasons that he doesn't know or doesn't understand, that because the curve calculator does not have a limit of diffraction element to it, it somehow has to be wrong. And when he is pressed on this, all he can do is repeat the same thing again and again. Watch him do it.
So, there's only one assertion made by the Earth curve calculator, in spite of the fact that things can disappear with distance.
Tell me all about it.
Yeah, just
How
did.
How can they disappear with distance?
Because they get too small to see.
Oh, please do.
They get too small to see. Their angle is too small. The angular...
What's the angle? What's the critical angle?
I'll say it again. Something that's ignored in your calculator.
I'm asking you, Nathan Oakley, to tell me what the critical angle of the human eye is that would make things...
I don't know. Hold on, let me answer him. I don't know.
You see what I mean? Now, poor Ranty Flat Earth is in the background desperately trying to help out Nathan. But Nathan will not allow anybody to help him because he's, well, Nathan.
It's okay, Bob. We all know there's only one assertion made by the Earth curve calculator. Earth curve.
Okay, I think we're going to see a pattern here. I think everybody needs to take a drink every time Nathan says there's only one assertion made by the Earth curve calculator, Earth curve.
However, the diffraction limit is real, and it's ignored in the calculator. Things definitely... Yeah, I hadn't finished. Things definitely do disappear due to their angular resolution, i.e. when the angle is too small, you can no longer resolve that item. So,
You are
that
correct.
effect, which absolutely does take place and is calculable. Do I know the calculation off the top of my head? No. Does it?
Well, I'm trying to help you here, Nathan. 0.02.
Who
There
cares?
you go.
Who cares? It's excluded from your maths. It's a real thing, Bob, and you're saying it's excluded. The only assertion is Earth curve. Well, other things do cause stuff to disappear in the distance, and they're ignored.
Well, the good news is you only have to take half a drink for that one. But he's really quite incorrect. There are other things that do make things disappear, and the Rayleigh Criterion is one of them. They're not ignored. They're reviewed and found to be insignificant and non-contributory to the curve calculator. That's why they're not in it.
All right, my turn.
Hey, Bob, I've got a question for you. If something's got an angle of 0.001 degrees, would you be able to see it from 29.3 miles away?
I don't think he knows. Nathan, would you like to know?
No, Bob, I'm asking you the question, Bob. Would you be able to see something with an angle of 0.001 degrees from 29.3 miles away that is only 3.2 feet in height?
You're saying you've used two numbers. Do you want
0.001? Yes.
No, you would not. You would see a point. It depends whether you actually saw it. It would be whether or not it was light enough.
Sorry, now, Bob, can you show me where that very real fact of life is accounted for in your calculator that says Earth curve is the reason it's not seen?
Yes. Easily.
Okay, go ahead.
How large would an object be at 29 miles if it was 0.001 degrees in size? You said 3 feet?
No, I didn't say that. How big would it be?
Well, you have to tell me how big it would be.
No, that would be an actual... Sorry, how big it would be? That would be an actual size, wouldn't it?
Yes.
Well, we don't see things in actual size, Bob. We see them in angular size. That's how this picture on screen now is comprised.
Okay, now either Nathan does not know what I'm trying to do here, or he does know what I'm trying to do and doesn't want to let me do it. I'm asking Ranty specifically, how high is the object that he's talking about at 29.3 miles? Is it 3.2 feet? The reason that I want to do this is I'd like to be able to calculate the actual angle. The problem that Nathan is having is that he wants to use angular size, but doesn't realize that that angular size does not change the physical size of an object. It's just you take the physical size of the object, you put it into the distance that object is away from you, and then you can calculate the angular size of that object.
So this tree here, Bob, in the near foreground, can you see it? It takes up 50% of the frame. Now that's irrespective of its feet and inches value. Yeah? This tree over here takes up a considerably less amount of the frame. Now that's an angular quantification of its size. Now it might very well be the case that this tree is in actuality much bigger than this tree, although it doesn't appear that way in the picture. So this would be an angular size. And if you push this tree far enough away, you won't be able to see it at all. The angle will be simply too small to see. This is ignored. Even though it's the absolute basis for how this entire picture is comprised, your calculator ignores it. And if this tree gets too small to see, the calculator says it's Earth curve that's blocked it.
Well, actually, Nathan, all you're really talking about there is perspective. If two objects of the same size are sitting next to each other and you move one further away from the other, the further object will appear smaller than the nearer one because of reduced angular size. That's just the way perspective works. Now, what you're attempting to do is you're trying to say that objects disappear because they become too small for us to see, based on the Rayleigh Criterion. I've tried to press you on this, and not only don't you know what the Rayleigh criteria is when I ask you specifically to cite the critical angle of the human eye that you feel accounts for objects disappearing. You don't even know what it is.
Well, we could put it another way to you, Bob, is that if you was looking across a Great Lake that was 29.3 miles, and let's just suppose that this lake is flat, just for argument's sake, right? So you have a clear
All
line
right, we're going to assume a flat lake,
Well,
29
I'll tell you
miles
what.
across.
Or we
That's
can,
fine.
or I'll tell you what, we could assume a globe Earth, and we are looking at Blackpool Tower that is almost all of it hidden, except for the top 3.2 feet of it. So you can choose whichever you want. But at 23,
no, it's your chicken. You cook it.
Okay,
you choose which one you want. Do you want flat or do you want to go up?
Oh well, I'll tell you what. Let's do globe. 29.3 miles away. We're looking at Blackpool Tower. And we're only seeing that, well, the curve calculators say that we should see 3.2 feet of it. Yeah?
I'll take your word for it.
Now, the conditions are perfect for standard refraction. It's absolutely nailed on for standard refraction. So 3.2 feet should be seen from 29.3 miles away. However, its angular size is only 0.001 degrees.
I think it's important to take into account the Rayleigh criteria here real quick. Now, again, and Randy is implying this, but I want to make this very clear. His question and my answers refer to the resolution of the naked eye. We're not talking telephoto lenses. We're talking about being able to see something. Now, at 29.3 miles, 1 second of angle is about 0.75 feet. He is saying that the object that we should be able to see is approximately 3.2 feet high. Now that is approximately 4.5 arc seconds in size. In order to be above the Rayleigh criteria so that we can see it, again, with our naked eye, it has to be at least 25 arc seconds from the top of an object to the bottom. This is well below the Rayleigh criteria for the unaided eye. Now, the problem that they're running into is a simple lack of understanding of what the curve calculator does. The curve calculator points out what is hidden and what is visible on an object more than, a certain distance away. Now, the fact that it is visible does not necessarily mean we can see it with our naked eye. Now, what I mean by that is, say we looked at this object with a telescope. That would definitely change the Rayleigh criteria. It would also change our field of view. At that time, with that magnification, we could probably easily see that 3.2 feet. However, no amount of magnification would be able to bring back the part of the object that is below the Earth curve. Now, simply because we can potentially see 3.2 feet, again, does not mean that we can see it with our naked eye at that distance. We could zoom in on it, but we may not necessarily see it with our naked eye. And this is something I think they fail to understand with this entire exercise they're trying to do.
The angular size of the 3 feet or the angular size of the tower? Okay, that's fine.
Of the 3 feet. So the curve calculator says that it should be visible. But the human resolution of the eye and optics and that narrow viewing angle over 29.3 miles away makes it invisible because you cannot see it. Okay, so we'll just off the basis of what I've just said, and just assuming that I'm correct with my calculations, and we have 0.001 of the degree, that is the height of this 3.2 feet that we should see over the curve, right? But that is the angle. Now, that's visible in the curve calculator, but it is too small to see.
Can you see it?
It is too small to see.
Okay.
And we're asking you, where is that in the curve calculator? Because that is all perspective. Perspective is things get smaller with distance. That is the technical term. If you look it up in the Cambridgeshire English Dictionary under nouns for perspective, that is what the meaning means. Things get smaller with distance, i.e. perspective.
If you calculated the angle correctly,
yes,
I would agree that that would fall below the Rayleigh criteria.
Yep.
If the angle is 0.001 degree, you would see a single point. And then whether you saw it would depend on how bright it was.
Okay, now for the reasons that I've previously stated, if his numbers are correct, it would fall below the Rayleigh criteria. And by the way, the Rayleigh criteria for the unaided human eye is approximately 0.007%. So that would be well below the Rayleigh criteria that we would need to be able to see that object. Now, at this time, I'm going to ask Ranty how far away a building 100 meters high would have to be to have a viewing angle or an angular size of 0.007. And the point of that was to show why the distance required for that is far beyond the distance that object would disappear behind the Earth curve. But, as always, either Nathan does not understand what I'm getting ready to get into, or he does, but in any event, he feels the need to cut me off and begin talking over me to prevent me from actually saying this, because he realizes perhaps that it completely guts his argument like a deer.
But I have a question for you then.
Sorry.
If
before
you
do,
have
why
a
is that in the
100
calculator?
meter tall building,
Why isn't that in the calculator?
it's generally not needed.
Sorry, you've just explained that stuff disappears with distance based on its angular size, and now you're saying it's not needed. The calculator will simply assert that it's Earth curve that's causing it. Well, it's not.
It is.
The angular size is causing it. You've just made that clear. Calculable in the Rayleigh criterion. And it's not included because it's not needed.
Nathan, I do not.
It is needed, and you're talking over me. I'll just shut you up. Yeah, that he's now going to argue the toss about Ranty about isn't included in the curve calculator. So anything that disappears with distance, according to the curve calculator, the only cause, the single cause, is Earth curve. Sod all to do with what he's now about to argue with Ranty about. It's not included and not needed according to him, even though it's very real and how we see things.
It has nothing to do with it. And
Sorry, I'll just do it again for this stupid asshole. This tree on screen takes up 50% of the frame, and I absolutely guarantee if it was 1,000 miles away, you would not see it because it was too small.
Now, right there, Nathan demonstrates one of two things. He's either obtuse or he is stupid. Now, to say that we could not see a tree 1,000 miles away due to the Rayleigh criteria alone is absurd. Could we see a tree 1,000 miles away behind the Earth curve? Of course not. Could we see a tree 100 miles away due to the Earth curve? No. Doesn't have anything at all to do with the Rayleigh criterion. So this is the logical error and lack of comprehension that Nathan is demonstrating. He seems to think that because the Rayleigh criterion is not in the Earth curve calculator, it has any bearing whatsoever on it. It does not. The objects will disappear over the Earth curve many, many, many times sooner due to Earth curve than they will due to the Rayleigh criterion. And this is his lack of comprehension coming out because he doesn't seem to grasp this.
The calculator would say sod all to do with how small it is and only Earth curve obstruction. Well, that's simply not the case.
Correct.
Things get too small. Not correct.
Hey, Nathan. Correct.
Things get too small to see regardless of your fundy belief in Earth curve. So, yeah, there are multiple reasons why things can disappear into the distance and you can only claim Earth curve obscures them. Wrong. Things can get too small and you can't resolve them. Nothing to do with Earth curve, completely ignored in your calculator.
And here's the problem. You understand that things can get small enough that you're not able to distinguish them, 2 points due to the Rayleigh criteria. That's true. The problem is you don't have any clue as to what that critical angle is. You don't know how to calculate it, and you have no idea what distance it is. The point that I am desperately trying to make here, and laughing at you for not allowing me to make it, is that if you have a 100-meter high building, that building, in order to meet the Rayleigh criteria top to bottom of 0.007%, needs to be 818,511 meters away from you. Now, Nathan, how many kilometers are in 818,511 meters? You've already shown that you don't know how to make that conversion. Let's see whether or not you have learned since that time.
Nathan, you can either keep talking or I'll give you a key example that will demonstrate this for you perfectly. So what do you want to do?
You're not explaining why it's not necessary in the calculator.
I will right now if you will stop talking. Will you stop talking and learn something?
Excuse me, who the hell do you think you are? Do you think you're more learned than me? Do you think you're somehow smarter than me?
Let's represent the Rayleigh
Excuse me,
Criterion.
who do you think you are? That's the question I'm asking.
Well, Nathan, I normally don't like to talk about this, but since you asked me directly, yes, I am. By far.
I'm somebody who actually knows the answer to this, and you carry on for your narrative and don't want to listen to answers.
No,
Now,
the answer's come. You've explained and discussed with Ranty how things that are too small disappear. The calculator doesn't account for it. The only reason things disappear, according to the calculator, is Earth curve. So whatever you discuss in detail about the Rayleigh Criterion is not included in your calculator, mate.
correct.
Not correct. Things do get too small to see. Angular size limitation is a cause of things disappearing in the distance. So it's not correct to exclude it.
Go ahead and I'm just going to go ahead and give it then. If you have a 100-meter tall building.
Sorry, 100 meters isn't how we see things. We see things in angles. Yeah? So 100 meters is an actual size. We don't see in actual size.
You know, Nathan, I almost feel like I'm talking to a child here. But let me try and put this in a way that you can understand. Simply because something is close to us or far away from us does not change the physical size of the object. You can take the distance that an object is from you and the physical size of that object and find how large of a viewing angle it is, okay? That's how you find the viewing angle. That is what I'm trying to do. So for example, if I have an object that is 10 kilometers from me and is 100 kilometers high, I can calculate a viewing angle for that. Now, whatever that viewing angle is, if that same 100-meter high object is now 20 kilometers from me, that viewing angle will be smaller, and that follows a formula. So this is the point that I'm trying to make with you when I ask or state a size of an object. Simply because it's a long way away from you does not change the physical size of the object. And that physical size of that object is important.
Nathan, are you going to keep interrupting me or
Yes.
do I just have to do this on my channel?
Yeah, you piss off. I don't give a shit where you do it. We don't see an actual size. I don't see a 100-meter building. I see an angle
Right.
to the building.
Now, listen, Nathan. If
Yeah,
you have
you will try and demand that we use actual size. We see angular sizes, not actual size. So your actual size is a geometric calculation that will exclude perspective. So I'm not going to have you
Okay, so you
start
don't
with
wanna know
actual
that,
sizes.
Okay, so the bottom line is that I gave Nathan the opportunity to discuss this on his channel. And he did not want to know. He does not want to know why the Rayleigh criteria is not in the curve calculator. I think all of us have figured it out by now. And the example given, or that was being given, was that a 100-meter high building would have to be 818 kilometers away from you before it shrunk small enough that you could not tell the top from the bottom, and it would simply be a point. Whether you saw it or not, it would be just dependent on how bright that point was. Now, that same 100-meter high building will vanish due to the curve at 40 kilometers, which is only 5% of the distance for the Rayleigh criteria. As a result, the Rayleigh criteria has no bearing whatsoever on objects vanishing over the curve. That's pure geometry. I attempted to make an explanation of this to Nathan. Ranty Flat Earth apparently seems to have gotten it a little bit, although his numbers are wrong. I sat down and played with the calculation a little bit. I don't know where he came up with the idea that the Rayleigh criteria for the human eye was either 0.01 as he used in one example, or 0.001 that he used in another example. But it's the actual Rayleigh criteria for visible light and a 5 millimeter pupil is 0.007%, or excuse me, 0.007 degrees. That's the second time I've said percent rather than degrees. Sorry about that, folks. But here's the problem that we run into with Nathan. Nathan is a theater major. He is not a learned individual in the sciences. And the way that you can tell is that if you are a learned individual in the sciences and you don't know something, you generally will go look at it and find out. How did I know that the Rayleigh criteria was 0.007 degrees for the human eye? Well, I took the formula for the Rayleigh criteria. I used a 5 millimeter pupil. I used a 500 nanometer wavelength for light, which is about mid-range in what our visual range is. And I calculated it because I thought that it was important to know. And then I used that calculation to find an example. And that is that the 100-meter high building would disappear at 818.511 kilometers. Nathan never followed through with any of that. He doesn't know what the Rayleigh criteria is because the only thing that is important to him as a theater major is his script. Now probably somebody a lot smarter than he is, wrote him a script and said press the Rayleigh criterion as the reason objects disappear. If you are pressed on it, say that, hey, it's not included in the curve calculator, therefore everything's wrong. Well, okay, Nathan, what is the Rayleigh criterion critical angle for the human eye? Let's listen to what he said again.
I'm asking you, Nathan Oakley, to tell me what the critical angle of the human eye is that would make things...
I don't know. Hold on, let me answer him. I don't know.
Okay, now here's the thing that Nathan doesn't understand, and that is that when I call into his show, it's generally to make a point. Now, I set Nathan up to fail by asking him questions I know that he cannot answer, and this is one of them. I knew for a fact that the only knowledge that Nathan Oakley has of the Rayleigh criteria is that it makes 2 points indistinguishable due to diffraction. He doesn't know what diffraction is. I don't think he knows what perspective is. I don't think he knows what refraction is. I don't think he knows the difference between any of those terms. He has no clue as to how diffraction limitations practically affect objects as they become more distant from us. Now, if he had any concept of how this could be used to make objects disappear in the distance, he would at least have known what the critical angle for the human eye was. It's not a difficult formula to do or an equation to work, and it comes up with a very specific answer. 0.007 degrees. Knowing that, you could at least figure out how far away something had to be. Now here's another key example. We've all seen photos of the Toronto CN Tower from across Lake Ontario. And oh my God, I can see the tower, blah, 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 blah. Okay? Well, first, you're only seeing about halfway up the tower because the rest is covered with lake curve. Second of all, would any of that tower disappear due to the Rayleigh Criterion? At 37 miles, which is the distance across Lake Ontario, the Rayleigh Criterion would mean objects would disappear if they were less than about 30 to 40 feet apart, okay? The CN Tower is far taller than 30 or 40 feet. And as a result, it's not going to disappear in any way, shape, or form due to the Rayleigh Criterion. Nathan cannot comprehend this. All he knows is that there is this thing out there that sounds important called the Rayleigh Criterion, and it makes objects disappear. And the Rayleigh Criterion is not in the Earth curve calculator. Therefore, he's hoping that you, the listeners, do not understand any of this any better than he does, and won't realize that he is simply blowing smoke up your distal GI tract. So, this is Bob the Science Guy signing out from Northern Michigan. Don't take any wooden nickels, and don't listen to Nathan Oakley tell you about science.
This rabbit hole's too deep for me. Feel my brain getting real sore.